Hi guys and welcome to another video. So let's continue with our project, okay, which is Myla. Let's continue with our project. We're gonna create a new branch now, which is going to be the 0.6. Okay. I need to check this on my GitHub. Lima Pedro GitHub. Let's see. It's not this one, this one. Let's see if we have this new branch to our GitHub. We don't have yet publish branch. And let's see what we got. I'm gonna come back and still don't see a change. I need to see if I'm doing this right. Okay. I don't think we have put anything yet. Okay. Okay, 0.6. Okay. So let's go ahead and I'm gonna open this on Visual Studio Code. And in the last video we were working on a text classifier to do a natural language understanding, and today we're gonna go ahead and finish this. So I see this here. I need to correct this. Tensorflow. Okay. By the way, I did fix the issue with Tensorflow that we had in last video, and unfortunately I cannot hear my computer right now. I need to add another headset, so I'm gonna go. Hi guys, I'm back, and it turns out my volume was just too low for me to hear anything. I did had a connected headset. So let's go back. So I did install TensorFlow, and I installed the version 2.2. Okay, let's go to TensorFlow. I have the version 2.2, which is quite recent, this one. So if I do pip show TensorFlow, I'm gonna get this output. So now we have TensorFlow. Let's run this example. Let's save it. Let's run. Okay, you need to pause this. Let's run Python and then u slash actually model. Actually is model.py. Let's see what we got. We can see that we have to, okay. So this is an issue that we're gonna have to solve today, and we're gonna talk about this quite briefly. So you guys can see here we got a key error D, which means that these keywords was not found on the dictionary that I've created. So to address this, I'm gonna talk about data legend NLP data, choose data tokenization. We're gonna talk about this a little bit. Okay. Tokenization in natural language processing, it has multiple levels, but if you follow this tutorial, you saw that we were working on a char level tokenization. Okay, so we were working with chars, which works quite good, except we have to have a defined vocabulary, and that's quite difficult, and it doesn't handle multiple languages. So let's go ahead and search for char versus char byte versus the other one is words or NLP. So let's see a little bit of the differences. We got some uh, algorithms here, byte pair encoding. Byte pair encoding is a very complicated and sophisticated method to work with natural language processing. But let's read, you guys can see here why you should care about byte level sequence to sequence models. So byte models, they have some cons that are very interesting. Small vocabulary, they can handle out of vocabulary words, which means that we don't have to specify a defined rule or vocabulary. It will be able to work with unknown or new words as well. So in the drawback is the length to unroll, but since we are not working with sequence to sequence this time. This should be just fine. So let's modify our model to work with sequence to sequence, and let's go. Okay, so we're gonna choose byte level because it can handle is a static vocab. Okay, static vocab. We don't need to change because we were using this char set every time we were generating a new vocabulary. And because we are using a static vocabulary, we don't need to worry about this anymore. Okay, we don't need this. Um, so it also handles out of vocabulary words. Okay. Okay. So to do that, uh, in our input data, let's talk about the shape of our array. So our array is going to have the following shape, which is the number of examples or samples, followed by the sequence length, okay, followed by the vocabulary size or vocab size, okay. So if we are working with this is for one hot encoding, which is what we are using, okay, one hot encoding. If we want to use sparse arrays or sparse vectors, we just need to copy this, and for sparse, okay, sparse encoding, we don't need to specify the vocabulary size. So there are some pros and cons from each of these approaches. We're gonna use the first one, which is a one hot encoding. So we got the number of examples, the max sentence, the number of characters. This time we won't use character. We're gonna use bytes. So the maximum number of bytes is 256, and the data type we're gonna pass float 32. Okay, so we got our array. Now we're gonna have to populate this array and initialize this array. So we're gonna loop through every example, and we're gonna get each character. Okay, but let's just do something very quickly here, very quick, which is to remove this input. Let's just put imp to avoid any confusion on the Python runtime. I'm gonna search for other conflicts. I don't think we get any. So let's go ahead. This doesn't exist, so we're gonna use the one hot encode still, but I'm gonna change this just a little bit. So to convert to get the value for each input, we're gonna loop to each input using the function bytes. So bytes from the input, we're gonna have to decode UTF-8. Okay, and this should handle multiple languages as well. So to get the value of the item that we want, we're just gonna use the function int and ch, okay, equals 1.0. So that's how we got our data to work with this. Let's go and call input data 0. Okay, let's run this. We don't have this output data yet. We're gonna have to work on this later on. Let's comment this by now. So let's run this, and we should see, okay, we got this output, which is quite messy. But if you go to shape, we should see the shape of the single data, which is 24 is the max, the sequence length, and 256 number of characters. So we got the data normalized. Now what we need is to get outputs. So to do that, we're gonna go. We need to create a now we need to create a dictionary to map each label. Okay, so we got the labels here, which is in outputs. So let's get these labels. Let's go here. Let me find a good place here. Okay, so to get the labels, we're going to create a set. Okay, outputs. So this is going to show me all of the unique labels that we have on this data set, which is going to be the entities that we want to recognize. So this is all the labels that we want to recognize. Okay, we get open Google, get weather, get year, get date, and get time. So now we want to get this. We want to get this and convert to that output that we saw previously. So let's create a dictionary called label to index to map a index to a label, or and we're going to create a index to label to map each label to an index. And let's go for k, which is going to be index label and enumerate labels. We're going to do label to index label equals k, and index to label k equals label. So by doing this, we're gonna get this dictionary, and now we can create the output data, which is going to be a list. And let's look through every label, and actually when I loop for each output in outputs, and outputs, which is outputs is this list containing each entity. Okay, so let's go ahead and to our output data add the index for each label. So to do that, we're going to do label to index output. So now we should have the output data. Let's print output data just to make sure that we've done this successfully. Now if you run this, okay, so here we go. We got 1 1 2 2 4 4 0 0 and 3. So it's all good. Now we want to use this function, which is to categorical from these are the classes or the categories that we have on our data set. Now we want to normalize that for one hot encoding. So we're going to use Keras to categorical, this function that is used for classification. Where is it? Here. We're going to do this. Let's copy, and let's, okay, we already have that. Okay, so let's commit this code. I'm gonna do with some updates. Okay. We change tokenizer from char level to byte level, and we did created the output data array. Okay, so this is what we did. Now let's commit this for GitHub. So we got the data. Now we need a model. And I was looking for ways to build a model on Keras, which were the most easy to implement. So let's go ahead and create a model here. Let's create a sequential model, by the way. It's going to be very easy to do. And let's add an STM. We're going to add an STM layer with 128 neurons. And let's add the dense layer, which is going to split the classification. And we need to define number of labels. Oh, actually, we didn't create our output data. Let's do output data equals to categorical output data, and the number of labels is going to be len labels. Okay, so we should be clear now. Let's pass len labels, and activation is going to be softmax. So let's do summary just to make sure what we got summary the model built successfully, and we didn't. Okay, because summary function is called in a static graph, and we are using TensorFlow 2.2, by the way. So now let's do the setting of the model. Let's set a optimizer, which is going to be Atom, the default, which is very good. Loss is going to be the categorical cross entropy. Categorical cross entropy, which is used for classification entropy. And the matrix is going to be accuracy. Okay, and let's do model.fit input data, output data. Epochs is going to be 256, which is we need a lot of epochs to run this. So let's execute, and we're gonna hope for the best. And let's see. Okay, we are running the model now. Okay, we were able to run this model. Okay, so now we have the model created successfully. Okay, so now that we have the model and we train the model, we need to test this. So to test this, we need to basically create a function that is going to classify. So let's create a function called classify, and we're going to pass a text. So this is going to classify any given text into a category of our NNU framework. Okay, so as I said before, it's all dynamic. If we add more data to this train.ml, and if it doesn't have contain any error or something, it should be all dynamic. We should be able to scale up our framework pretty quickly. Let's go, and now we're gonna create an input array. Okay, and input array is going to be x input of zeros. The first shape is going to be 1 because it's a batch size of 1, and the max sequence is going to be max sequence, which we got. Okay, max sent actually, max sentence, and the number of tokens or vocabulary size is going to be 256. Let's pass the data type is going to be float 32. Got this. Let's run a quick function to enter it to each character and get its value in bytes. It's going to be text dot encode and tf.8, and because x is gonna assign for a first index, which is 0, we need to pass a index of say 0. Okay, we could create a simple array and expand the I'm gonna show you guys how to do this. We could create, you could remove this and add later on, but I'm gonna create now. So max is going to be k, index k, and int ch equals 1.0. So this is how we got the input data. We're gonna fill the x array with data from input text. Okay, so the output now, let's go out. It's going to be model dot predict. So we pass the x to the out, and now let's say I want to get this is my final output. I want to get the index of the highest score because we're doing classification, and to get the index, we're going to do out.argmax, which is a function that NumPy arrays have. And now I'm gonna go classify this. Let's go the text. Let's pass text. Let's put this here. Is classified as. Let's put the actually I need to do this way. Okay, dot format. So we're gonna pass a text, which is going to be text, and now we're gonna get the index. So this is the index. We can now get the label or the entity by passing the index into our dictionary. Label to index, index to label, actually index to label, pass index, and now we are done. So I'm going to create a quick function here, while true, at the end of the file, entry or text, I don't know, input text equals input, enter some text. We're gonna give some text to test it out, and let's call classify text. Okay, so this is how we're gonna classify text using this library. Let's run now, and if everything is fine, it should be all good. Let's wait a little bit until it runs this. Okay, it's good. Let's enter. We want to go here. So if I go with, I don't think I have a function for year yet. Okay, but okay. Tell me which year is. And we got text, and there we go. The output is time/getYear. How's the weather? How's the weather? And there we go. We got weather correctly. Tell me the time. Get time. Okay. Tell me the date. Tell me the date. Okay. So the mod is working. Mod is working. And we need more data. Okay, we basically need more data to scale this up, but now we already have this model working. So this was the video, guys. I've committed the last part of this video. We successfully added the model classification text to our project, and the next video we're gonna go in more things in our project. So see you guys there, and thank you for watching.